everyone. Yeah, the music source. This is from, I think, Fan Zhongpei. I think he was a music maker for mainly movies and commercials. But this was originally Deng Yuxian's song called 帆社姑娘. Okay, so that should be pronounced in Taiwanese, I suppose. So, hey, good morning, everyone. Let's go over the announcements. How about that? So first is, of course, the video session as well as the Google Meet session. Yeah, some of you started working on PA3, so the GIF from poly.txt files might work okay to upload. But for some other files you want to upload, it might fail. So go to the PA3 channel. Poly has provided a few reasons why some other files don't work. So you see why these protocols need to be well defined. Otherwise, client think this way and server think another way. Client expecting all files being uploaded, but server was assuming, right, the files will come in certain format. Then there'll be mismatch and the protocol won't work. We don't communicate. Okay. So in a way, PA3 and PA4 is to show you that if the description is not exact, not precise, things like this might happen. Okay. So GIF from poly.txt is a text file that Poly's server there sitting on 12,000 is expecting. When you're working on PA4, you will see also more. Exam number 1 is just around the corner. Okay, so this is probably a news that's a little bit devastating for you, because this is only like week 5 and next is only week 6, and yet we have an exam. Yes, we do have an exam. Okay, please go to this channel here, exam 1. You will see detail there. So let's go there together so you could see a few important things you want to know. So I just click into the exam 1 link and it takes me to the exam 1 channel. Now, I guess you guys will need to add the exam 1 channel first. Okay, join, and then the Slack will take you there. All right, so exam is gonna be on Thursday next week. Okay, it's gonna happen exactly the time that we have the Thursday lecture. It's gonna be 100 minutes long, but the actual time that you'll be writing the exam might not be all that long. Okay, so there'll be some time buffer at the beginning, so Poly can check your IDs and make sure that your camera is pointing in the right direction. And there'll be also some time that we will close the session, okay, and allowing you guys to move on to the next lecture. Point number 2, the exam, as you are aware, is going to be in Google Form. This is very new for all of you. Please do go to the old exams and try out those exam Google Forms, so you get used to doing an exam on a Google form. By the way, you will need to log into your Gmail account in order to work on the Google form. It doesn't need to be the same account you use to communicate with me, okay? Because on the Google form, I will ask for your student ID. That's how I identify you. Point number 3, you will need to also join the Google Meet session that every one of you would join simultaneously throughout the entire exam. Okay, and this is per university regulation for fairness purpose. Okay, so the next Wednesday, okay, we'll start a testing session. So you guys will all join. Okay, so that will be 10 minutes before the lectures on Wednesday. So I will start the video session at 1:10. You guys will join and you will get a feeling of how it's like. And you can try out your camera, whether that angle is okay. Some of you do use cameras with really low resolution or your network connectivity allows only very low resolution. That is probably fine, but you do want to try it out and see if you show the student ID like this, probably you'll be able to recognize the picture and the name on the ID. Okay. So in a way, Wednesday, 10:10, go to the places you plan to take the exam and use the network there and use the device you plan to use to do the exam. All right. So let's not go over the detailed description, so please do read through the whole thing so that you are aware what you need to pay attention to. By the way, the exam is going to be super long. The point is so that you'll be busy answering questions instead of trying to talk to the other students. Okay. Of course, you may not do that, but I understand that sometimes it's a little bit hard to resist. Okay. It's open book, open internet, so you are free to look up the internet by doing Google search. Okay, it's okay. And the sites are going to be there. The videos are going to be there, but I suppose reading the sites or going through the videos will be too late. So you do want to know the stuff very well, but you don't need to memorize things. You could have a cheat sheet next to you, but cheat sheet is more like a notes, a concise notes next to you in case you forget about a certain term. Okay, so after fill out the basic info like name and student ID and stuff on the Google form, you definitely want to submit the empty form first. That way you get an email back from your Gmail account, the link to the form. So you can always come back and use the form to fill out information. And you do want to submit somehow. Okay. You will receive a link. Yeah, so you might want to submit the form multiple times during the exam. So only after you submit, whatever you type up are committed to Google's database. Okay, but you do not want to do it too frequently because it takes time for Google to complete the submission. So you might want to set a goal for yourself, maybe like every 30 minutes, every 20 minutes you submit. Or you feel like that you answer enough points. You want to make sure that you get all these points, you submit. Okay, so the submit is almost like what you call flush in Golang. That is to push the data out into the file. Okay, because when you write data into a I/O, sometimes they are only in the temporary buffer. Only when you say flush, then it's officially out. Okay, out into the file, out into the socket. Okay. Now, of course, the operating system will also have a mechanism, but you are not aware of the exact mechanism. Every now and then, if the operating system recognizes the buffer is close to full, operating system pushes the data out. This is a little bit similar, except that you have to be your own operating system and decide when do you flush, when do you submit again. So you can submit multiple times and come back to the form to continue modifying the answers you've had filled in before or adding new answers for the next set of problems. And some exam questions will ask you to log into the PA servers because these are questions testing the practical skill, whether you're picking things up, okay, learning Golang and learning doing socket programming using Golang. Okay. We'll disable the firewall during the exam so that you don't have to do VPN. So this is to avoid network issues, stability issues. Sometimes it's not because your network is not stable. It might be because the university computing center's VPN server not being stable. So let's try to eliminate firewalls so that we could reduce the effect of unstable VPN servers. Each of you will receive your own account for the server. So for the PA assignments, each group receives an account and you work as a group on the account. But for the exam, to avoid that you copy each other's solutions within the team. So each of us will receive an account. The former exam resource. Yeah, Liang Yu, that's a very good question. You see that it's a very important question as well. Good that you ask. Some of you might not quite aware of it. It's from the course page. Okay, so you see the course page. You see golfer up there. Okay, many of you probably just find golfer cute and then did not scroll down further. You see that down here, there's an exams link. If you click in there, you see, oh yeah, there are description about how we're gonna do exams. Okay, and there are some basic rules. Okay, so even though the poly is announcing these things using Slack, definitely still read through these. Okay, there are some additional advices as well. Okay, and also why we do it on Google Form. All right, so basic rules, system action requirements. Okay. This is to make sure that you are not tested. You are not tested of your troubleshooting skills. Okay, troubleshooting your camera, troubleshooting your network at the time of exam. So you want to make sure that all those are troubleshoot, and so that during the exam day, during the exam time, you focus on the problem sets. Okay, you focus on answering the exams instead of trying to hack your systems to make sure the camera working, the network working. The Google Form is working for you. Okay, the Google Form API is working for you. So you want to make sure all these other things are working for you first. All right. Okay, so handling anxiety, because for things that are new, I understand that it's hard, right? Emotionally, it's a little bit more stressful because it requires higher cognitive load to get used to it. Or just there to check you are doing your test by yourself. I wonder, are the PA really problems asking us to do something on the workstation, or they are just there to check you are doing your test by yourself? So I'm actually not quite sure what the question was. You might be asked to write a program right there during the exam time. Is that what you meant by doing something on the workstation? To check you are doing your test by yourself. No, it's definitely not checking whether you are cheating. I think I get what you were asking, Boris. Yeah. You'll be asked to program. Or given a program, you need to modify it such that it will work a certain other way. Not quite the way what Poly asks in PA2 or PA1 or PA3. Just to make sure that you are doing the PAs, not trying to cut corners. You see that that also makes sure that you learn, in case you haven't. So the solutions will show up after the grades are out. Okay, so this is the link to get to the solutions. So you could check where might went wrong, where you might have thought wrong. And these are the old exams. Spring 2021, there are 4 exams, in fact. So you guys were lucky, there are only 3. But you see that in spring 2021, we anticipate that the students might not do well the first couple ones because this is a very new form of doing exams. Students have all sorts of issues, networking issues, camera issues, VPN issues. And they are probably not aware how much time it might take to write the program if you are not familiar with the APIs, if you don't understand what the APIs meant. So, in a way, when you're working on the PAs now, if you went through trouble hacking and finally get through and understand exactly what that API does, that's good for you. Because in the exam, you will know exactly what might went wrong, and so you know what the fixes are. All right, so that was the page. I hope Liang Yu, you see a little bit better where the all exams are. So if you click exam 1, that should take you to the exam 1 Google form. Oh wait, no, this was the answer. This was the answer. Oh, okay, I think the Google form is up here. Yeah, so this was spring 2021, the exam form for the exam 1. Okay, so if you're filling this information and click next, then you go on and you can start working on the all exams. And after you've done one pass, you could check the solutions here and see how many points you might have received. Jiayo is asking, is there any requirements for the angle of camera? Very good question. Very good question. We need you to show from shoulder and up, so we see the face. I think if you read through this, you should see the requirement camera, so that you face from so that your face from shoulder up is visible throughout the exam. All right, very good. And Yunqi, does everyone get an account, or every team do? You know what? Every one of you will receive an account. So I'll be releasing the account later this afternoon or maybe early tomorrow morning. You guys will be given the same password for all, okay? And the account username, it's okay, Yunqi, I know. Yeah. Hey, grammatic error is not an issue. Okay, spelling not an issue. Just make sure that the poly understand. So you'll be given an account, and that will be the username will be exactly your student ID, but the password will be the same. The initial password will be the same, and so you do not want the other students being able to log into your account and see what you do. So definitely, the first thing you do is log in and change the password. Okay. All right. But that account, later on, after the exam, I'll close it so that you cannot change further. Okay? So that was only for the exam purpose. But we will we'll reopen the account for you for exam 2 and for exam 3. All right? So I think that was mainly all the content I want to communicate about the exam. The exam scope is PA1 to PA3. So you see that the PAs are in the exam. All right. So some of you, I know that some of you guys learn by just following examples. Okay, that's exactly how I have designed the labs. Okay. Because reading through the APIs, understanding exactly the APIs do take time, and we don't need to like crash you guys through the whole thing and learn Scikit in a short time. Scikit programming using Golang in a short time, so I take a very different approach. Yes, it's open book, open internet, and you can probably find a copy of the textbook on the internet. So you can go to the course page. And for example, go to the sites links and still when you're taking the exam, review the sites if you want. Okay. ID, name, and email address. I wonder, should email address be NTU email address? It doesn't need to be. It doesn't need to be. It can be your Gmail account as well. Okay, so that email is just an information, because I think later on when I release the grades, because Google form also has this exam form or quiz form. So after I finish grading, I actually say release the grades. And you would use that email to receive the grade report. So for each problem on the exam, how many points you receive. Okay, and you might also see what the solutions were. So that email address on the Google form are for you to receive grades. for the particular exam. Okay, so it's your preference then, Okay, so it's not Poly needs it for grading, for recording. So I use the student ID to make sure that I have one-to-one mapping. That email address is for you to receive your exam grades. Very good questions you're asking there. Hey guys, ask away. Make sure that there's no confusion. Now, but you also see there are informations already available. Pay attention to these as well. And of course, there's next Wednesday, and in between now and next Thursday, there's also Slack. So go to the Exam 1 channel here and post your question down here. All right. Oh, and guys, last but not the least, I understand. I know. Feel free to ask, definitely. But you also see that some of the questions we could actually answer or exchange offline. Definitely, you will get the account before the exam. Yes. You will receive the account either this afternoon or early tomorrow morning. You see also that from each of these accounts, special accounts, please do limit yourself from using 2 SSH login. We cannot have too many SSH logging sessions in parallel. Okay, so restrict yourself only 2 SSH sessions. And you see, Poly will also be monitoring. If I see more than 2 sessions from a user, I actually killed kill the extra processes. So you might be working on something, and in the middle, Poly kill the extra session. So if you limit it to within 2, then you'll be fine. All right. Hi. Okay. Yeah, so Yunqi joined the Exam 1 session. All right, good. I know you guys are probably not expecting Exam 1 coming up so fast. But hey, lots of love here. Exam is for you to confirm whether you are picking things up okay. And so if you do want to, show whether you really know it well before the exam, go over the stuff we have went through and, write down the important things, have notes next to you so that you could refer to quickly. The point, usually what Poly does with the exam is to make sure you learn more. Okay. So, hey, Poly won't see you any differently, okay, in terms of the grades you receive. All right, so that should be enough announcement, and let's come back to the lecture. But you know what? We kind of landed in the middle of a quiz last time, isn't it? So that was quiz, I think. Oopsie. Quiz 11. So the question was, how come SMTP runs only from the email sender to the receiver's mail server, not all the way to the email receiver? Okay. Yeah, so we actually we see already many teams typing up their answers on Slack. Okay. So essentially, perhaps Poly can just summarize the answers, different perspectives from all of you. One is, hey, IP address, right? Bob's IP address. How does the receiving mail server know Bob's IP address? That's the main challenge, isn't it? So Bob might not be online at the first place. No IP address. Okay. Now, if Bob is online, how does the mail server get the IP address? And nowadays, Bob may be online from multiple devices, therefore multiple IP addresses. Okay. So if we do SMTP all the way to Bob, there is definitely extra mechanism required for the mail server to discover where Bob is. Okay, and mail server there for Bob needs to store still mails temporarily for Bob, and sometimes push data out to multiple devices. That's more resource, more mechanism. Okay, now the second set of solutions are more this. It seems that because of the usage, how we read emails, you see earlier we are going on and off, intermittently connected onto the internet. I mean, speaking we, I meant the users. And we could also simultaneously accessing emails from multiple machines. It seems makes better sense that the emails are stored somewhere fixed and we can access 24/7. Right? Instead of all stored or locally on our laptop. What if I move somewhere else and I want to access email and I don't have my laptop with me? Then I won't be able to see the emails. Okay? So the communication model is supposedly better that from receiver, email receiver, to pull emails. And pull in a way that I just want to see the emails on a server somewhere, right? Instead of getting everything locally on the hard disk. Okay? So it's more usage model. That decides also the architecture of email transmission. So one is technical difficulty of getting the IP addresses, or resource consumption, pushing all emails, multiple copies to multiple devices. And the other is usage, okay, lifestyles. Okay, we now have smartphones, pads, personal computers, laptops. We have so many machines that we have access to. We call personal devices. All right, and now we move on to the topics today. We are not quite yet done with the emails. Okay, so this topic here is for you to see the message format, and you're gonna see a demo as well. So let's take a look at a demo first. This is a very simple SMTP exchange. Let me explain the notation. S being the server, C here being the client. Now in SMTP, this is the receiving mail server, and this is the sending mail server. Once the TCP connection is established, the receiving side identifies itself first. 220 hamburger IDU, status code, status phrase. Client here then would in turn tries to identify itself as well. Crepus.friends, that's the identity. And hello here is the command to allow the server to know who the client is. And then server, status code 250, everything is fine. Hello, Crepus.friends. Then beginning from here, we start to see control message exchange. Client here needs to specify who the sender is and who the recipient is. So mail sender is Alice and mail recipient is Bob. So all capital here, mail from. All capital here, receive to. Okay, our special commands as well, just like the hello. So whatever comes after the columns are the mailer and the recipient. So server again are just saying, okay, good, I got it, 250. And from here on, this is the actual data exchange. Data, once again, a command. Email starts from here. Do you like ketchup? How about pickles? And it ends with a single line that has only a period. Okay, so the actual email message is only this short 2 lines. Last is here, just to close. Okay, server will say, message accepted, everything is fine. Client then issue yet another command to quit the session. Server says, all right, goodbye. Very simple. To set up connection, to do the email exchange, and to close the connection. In the email exchange, there's the control message part and then the actual data part. And that is an SMTP message exchange among the client and servers. Let's try now to telnet to an actual mail server at port 25 and see what the server would send back to us. And then we could try to typing some of these comments out and see how the server responds. So let's go to the demo mode. Now let's try telnet to a mail server at port 25. Telnet, which mail server? Actually Googled up Gmail's mail server. The name is this, SMTP, how appropriate, gmail.com, 425. There we go. IP address being 64 something something. And this is the message coming from the server, 220. Alright, so SMTP, gmail.com there is identifying itself. And then ESMTP, okay, it's saying more. I'm not quite sure what this is. Right, so E must be something and then SMTP. So this might be a special variation of SMTP, maybe the encrypted version, I'm guessing. So let's try typing up some of the comments. For example, hello, and coming from us.edu.tw. How about that? Great, seems to be working. 250. So the server say, ooh, at your service. That's really polite. All right. Then let's try the next comment we saw earlier, mail to. And let's have Gmail sending to Polly's email address. How about that? What is this? 530 5.7.0 must issue a start TLS comment first. So yeah, it does look like it's trying to establish an encrypted connection. So TLS, if you recall, is what? Transport Layer Security Support. So I'm guessing this is probably the credential, the public key. So I'm supposed to send back the shared secret key with the public key as the key to encrypt. But I don't know how to do that. So yeah, let me try it again then. Playing dumb here. Polly Huang at ntu.edu.tw. Let's see. No, it's not accepting it. So I have to, yeah, so maybe recipient from yeah, Polly's Gmail address. How about that? No, it keeps bugging me saying, okay, let's do start TLS. So let's issue this comment, start TLS, and see, start TLS. Oh, cool, it's accepting. That's nice. Ready to start TLS. All right, so then I suppose I need to send back the, I'm already out. So it seems that the establishment process there also has a time limitation. Otherwise, yes, and hacker might be able to hijack something that you have done in the middle. Interesting. So, hey, I got kicked out. So Gmail is a secure email service. Email messages are encrypted. Nice. Good to know. And so that was a demo of trying to telnet to a mail server, actual mail server. You could also try this yourself, maybe from the workstation. Okay. Yeah, sorry. Yeah. So maybe I'll just not close it. So if you hear me drinking water, pulling water, okay, excuse me. All right, so I think the audio is back. Chumao, you might be wrong. Sorry, Chumao, you are right. So Polly couldn't hack a Gmail's mail server yet with Telnet. It's probably because Polly used the command wrong. It should be mail from and received to. But I think chances high you guys can try, because if you log on to the PA machine, you could also do telnet and try it yourself and see if you manage to hack through Gmail's mail server. All right, so there was 2 questions, one from Liang Yu, one from Chun Mao. Liang Yu was asking, it seems that Alice is using an email reader. Bob is also using an email reader, right? Alice is using the email reader to send email. Bob is using the email reader to read email. Okay, the reading side seems to be using some sort of access protocol. Okay, as you see from quiz 11. Sender side, when Alice is sending email, it's calling SMTP. So obviously, the readers, email readers, that program implements both SMTP, the sending process, as well as the access protocol. Okay, so very good observation. The email readers nowadays all have both mechanisms, both protocols implemented. Chuma was asking, what if in the middle of your email content there's a dot, okay, and that's there's a period for the whole line, and that's it. Okay, well, you know what? That's gonna end the email early. Okay, so as an email writer, you want to avoid generating an email where you have a dot in one single line, appeared in one single line. Okay, otherwise, the rest of the content will not go out. Okay, hey guys, think of it this way: the opportunity for class participation. Okay, all right. Oh, Yunqi was asking a question. What does start TLS do? That's a comment, I guess, for a TLS-based SMTP connection. So I guess there's another set of comments defined to do SMTP communication in case the transport layer protocol you use this TLS. So it's to start TLS such that it's a secure connection. TLS, recall, I think in the end of 2.1 we introduced TLS. It's the secure support for the transport layer such that we could encrypt the data, okay, from application down before passing it out to the transport layer. So start TLS is probably starting a TLS connection. But Polly was guessing. Okay, I don't know exactly how that is implemented for Gmail. It might be general for all the TLS-based SMTP. So guys, you guys can try to look things up, okay, and let me know. All right. But that was just demo. Okay, next we'll be looking at a few more things I want to say. This is particularly about the data part, right? So we have these send from, receive to comments, but those are to establish connection knowing which mail server to push the mails to. After data, D-A-T-A, all capital, then we have the message, okay? You know what? That message itself also has some format. So for example, one sentence would just appear. That's actually some sort of protocol design as well. And that's defining where the message ends, where the data part ends. Okay, so we're gonna see more definitions, okay, more rules about how you specify that data part of the email. And just a few words about SMTP at the end. Once it sets up a TCP connection, the client there can use the connection to send multiple emails. So it runs just like the persistent connection we see in HTTP. SMTP requires text in ASCII code, very strict. And SMTP uses just a single dot in the last line, okay, to determine whether it's the end of the message. Now, if we compare SMTP to HTTP a bit more, they differ in multiple ways, but they are also similar in another way. So this is the first thing they're different. Yeah, the service sort of direction.
HTTP is actually to pull objects down, but SMTP is to push objects out. Now, object here I meant email. They are similar in this way. Comments, responses, all these messages are in ASCII text format. But HTTP and SMTP are also slightly different in this way. Each object is encapsulated in a response message. So HTTP server there sends one object at a time, one object per message. But SMTP can send multiple objects in one message. That message is just having multiple parts. So for emails that comes with an attachment, like a big PDF file after, here is the attachment, if there's anything wrong, contact me. So email, the original text at the beginning, and then additional attachments. They can be sent as a multi-part message. So multiple objects in one message versus HTTP. One object, one message. Mail message format. So there's yet another protocol that defines how the email messages should look like. So this will be the data part of the SMTP protocol message exchange. If you recall in the example earlier, there's the opening phase, some control messages being sent, and then comes the actual data before closing. So the mail messages here we're talking about is the content being sent in the data phase. All right, so these messages are not control messages for SMTP. So they are not SMTP. The mail message format is actually defined in another RFC. It's another protocol. So in that protocol, it defines the mail message format. There are two parts only. The header containing a number of header lines, specifying who the receiver is, who the sender is, and what is the subject of the communication. In the body, very simple, just the content of the communication. So note again that I tried to clarify. In SMTP, you see mail from. So this sounds like, following this command, you also tell who the sender is. Receive to, after the comment, after the column, you give the recipient's email address. So it sounds a little bit like the to line in the header line and the from line in the header line, but they are actually completely different things. These go in the data part, while these go earlier, setting up a connection ready for data exchange.
All right. So there is a question from Jiawen asking if we are only reading emails, how do we, and not sending any emails, how does the SMTP work? Am I a client or a server? Okay. So the answer is that when you are only reading emails, it's the mail access protocol working. Okay? And you are the client of the mail access protocol. But when you are sending email, it's SMTP working, and you are still a client of the SMTP protocol. Okay. Boji was asking when it's CRLF, what does it do to terminate end of message? Yes, Boji, as you saw in the demo example there, right? A simple dot appeared there, ends the message. Exactly. CRLF is character return and line feed. Those are characters that don't show, non-printable characters. Okay. So in the protocol, the exact spec is that it's not quite just a period. It's a /r/n period /r/n. Okay, so you need to send exactly that string in order for the mail server to know that in order for your mail client program or the mail server program to recognize this is the end of your email, the content part. All right, so let's move on to finally introducing the mail access protocol.
And then we'll switch gear just a little bit and talk about the last part of email application. So we've talked about the flow of sending an email all the way from Alice to Bob, right? So mail access protocol runs here. Okay, so it's this part of the entire flow. SMTP that we talked about earlier only covers email exchange to the receiver's mail server. In between the receiver's mail server and the actual receiver, it's this protocol that's controlling. So what it does is to allow the receiver to retrieve email from its local server. There are three very popular mail access protocol: POP3, Post Office Protocol, IMAP, Internet Mail Access Protocol, and HTTP. These two, you can see that they are more specifically defined for the purpose, allowing a receiver to retrieve email. The functionality is also similar. First, the receiver needs to authenticate itself, authorize itself, and then begin downloading emails. IMAP, being a slightly newer version, it includes a number of other features, including, for example, we could store the email messages in a more structural way. For example, creating folders and putting certain emails in certain folders. Right. HTTP, however, is special. It's quite fashionable these days. Some of the mail service providers are asking us to use a web browser as the user agent. And then the email server there is essentially also a web server, so that it runs HTTP in the middle and treating each email as a web object. So fetching an email, fetching a web object. Okay, it's the same thing except that the content is more specifically being emails. And let's take a closer look at how POP3 works. Okay, the exchanges between the client and the server. The notation is very similar to the exchange we saw earlier in SMTP. S being the server, client is C. So there's an authorization phase and then the actual transaction phase. So authorization phase you see here, the client comments very typically being declaring the username and declaring the password. So you see here, in the authorization phase, server says, okay, I'm ready. Client says, I'm user Bob. So the username there is Bob. Password, being hungry. Right? And server responses with either okay or negative error. It's even more simpler. All right, so okay here, okay here, okay here. Maybe with the phrase after that. And in transaction phase, this is where the emails are actually retrieved. So client sometimes say this, list. So this is to ask the servers to tell back the list of emails there are. So this is more the index of the emails, and a lot of times just containing the file size and maybe the subject line. Right? It's only until the client begin issuing comment like this, RETR. So this is for retrieving messages. So RETR1 indicates that it's retrieving this email. So this is the index of the email, the size of the email, and there could be other information. Then the server sends back the actual content of the first email, and again ends with the period, and only one period in the whole sentence. Right. The client can actually delete an email that has already been read, or in case it's a spam. Right. So DELE, very intuitive, being the delete. Quit, also intuitive, being quitting the session. All right, so retrieve an email, server sends an email, client delete an email, retrieve another email, server sends another email, and client deletes yet another email. Q and then plus OK, server says goodbye. So that's an example of POP3 exchange.
All right, so that was, oopsie. That was, one second, sorry. Okay. That was email. all of it. Next topic is DNS, but it's time to take a break. Yeah, so that's why don't we take a break and then we'll come back to Yunqi's question. Yeah, so we spend too much time talking about the exams. But you know what? One thing that people ask me about doing online courses, how it's different to the professors at NTU, because they were curious about teaching in English and teaching online. And I said that students are a lot more interactive when they're online instead of being in class. I get lots more questions teaching online, even in English. So yeah, that's interesting, isn't it? Let's take a break. Come back at 11:21. Yeah, you guys are very lively on YouTube chat. It seems that this way you are more comfortable showing yourself. Okay. Very interesting. I know you've all maxed out your typing skill. I know. 那个技能点满了。Very interesting. I think even if professors are lecturing in Mandarin, being online, I think you guys ask questions easier as well. Somehow you guys just don't talk all that often directly to all people. Not that I admit that I'm old, but that seems to be the case. Okay, it's time. Let's come back to the Q&A from emails, particularly the email access protocols. So Yunqi was asking if IMAP can manipulate the messages on the server, for example, send them to different folders. It seems that we could also issue commands from the user end, right, to have the server do something and moving emails around. So would that make IMAP a pushing protocol? Arguably, yes, because you kind of move the messages around. You could actually download a copy of it, but you could still have it restored and move to another folder. So I think in a way, that's a very interesting perspective. Okay. Probably okay to say the pushing protocol, but it's not very clearly pushing. It does move the messages around. Qi-en and Min-hong are actually asking a similar question, okay? Because POP3 there delete messages, and POP3 delete the message mainly because yes, that requires memory space, hard drive space to store the emails. POP3 was an old mail access protocol because at the time there are not many people using emails, and for example, not like today, we might be receiving emails like tens and hundreds of them a day. So POP3 there, removing the emails, I think is the right choice at the time because we download and it's not much space from the local side. But if POP3 is serving many users, that's a lot of burden there for the server. Okay, and for the purpose of accessing emails, they thought that that's probably an overkill to store everything. But the emails are becoming important, so IMAP becoming more popular. And instead of keeping the emails and large quantity of them on the laptop, as well as our desktop and everywhere, it makes more sense to store it maybe on Gmail server. And we pay a small amount of fee to Gmail, or we watch the advertisements, okay, from Gmail every now and then. There's another question from Ming Hong. In Gmail, there is a retrieve email function. Yeah, there is. Okay, the way the Gmail reader works is that how do we access the email, the mail server, our email server? We could do it periodically. The mail reader here sends a message to check whether there are more emails going into our inbox. But in case we don't want to wait, we could trigger the mail reader to read if there's any new messages in the inbox right now. Okay, so that was what the retrieve mail function meant. But nowadays, we don't expect the emails to be responded in minutes or 10 minutes or even longer. So with the frequency of 1 read per 10 minutes, it's very reasonable. Okay, I think my Gmail reader is checking every 10 minutes. Okay, and you can configure that frequency as well if you go to your Gmail setting. All right, so if you are someone, working around the clock, gotta have the message right now, then you could set it to a very high frequency, like 1 second per check. All right, and now let's come to this topic, DNS. It's one of my favorite subjects in Chapter 2. Okay, let's learn about what DNS is trying to address first.
Next is Chapter 2.4 DNS, which stands for Domain Name System. And before we talk about the purpose of it, let's talk about identifying a person. If I tell you my social security number, my name, and my passport number, which one would you think would be easier to memorize? Well, social security number, 10 digits long. Well, the national ID of Taiwan is also about 10 digits long. You can correct me if I'm wrong. Name, Polly Huang. Passport number, don't even bring this up. Polly does not recall her passport number, as a matter of fact. So very obvious, isn't it? The name is so much easier. Well, that's just how human brain works. Name, form of ID, much easier. Number, form of IDs, harder, especially when it's a long sequence of numbers. Well, internet, to identify a machine on the internet, shows a similar obstacle. So hosts and routers, many of them have the IP addresses, right? But these IP addresses are even harder to memorize, maybe harder than the passports. And as you're working on the PAs, right, memorizing the IP address of the workstation, super hard. Even though you've already worked on it for a while, if I ask you to type it up, it's probably still challenging. So, what we do here on the internet is to give some of the important machines also a name. For example, www.yahoo.com here is the web server of yahoo.com. So you could just type www.yahoo.com and it quickly leads you to Yahoo's website. Similarly, www.google.com, quickly we reach Google. So, hey, how does the web browser know what is the IP address of the web browser given just www.yahoo.com? Well, that is the functionality of DNS, to identify the mapping between the IP address and the name. And let's talk about DNS more formally. So essentially, it's a database of these mappings. So lots of these IP address mapping entries. Nowadays, it's distributed, meaning there are multiple of these name servers. And there's a hierarchy actually connecting these name servers. Some of them sitting at the higher hierarchy and some of them sitting lower. What's a bit special about DNS here is if you hear me saying that, hey, a web service will need to query DNS system in order to find the mapping. So, hey, web service is already an application level service. HTTP is already the application layer protocol. So it seems that the application layer protocol, HTTP, there needs to work with DNS, which is also an application layer protocol, in order for it to operate correctly. So, DNS, in fact, work with multiple of these application layer protocols, not just HTTP, all right? So, name servers there would help all these application layer protocols in order to resolve names to the IP addresses. It's a very essential function. Some might argue that it's one of the core internet functions, which might sit underneath the application layer protocols instead. But now we put it at the application layer such that it's only running on the end hosts. If we need to update, improve the DNS servers, we don't need to actually go ahead into the core of the internet, all these routers, to change everything. So that makes changes a bit easier. Right? So there's a very special phrase that the internet designer would like to say, which is complexity at the network's edge. What it means that if you come up with something, some function that's very essential and it could go complex, then let's put it at the edges. Let's have it running on the hosts instead of running in the routers at the core of the internet. Okay. And a good side of doing this is so that we could evolve quickly and the performance bottlenecks can be removed quickly. Right?
So you see the point of DNS, mapping from the name to IP address. And it's about the most fundamental application layer protocols there is. All the other application layer protocols use DNS. And DNS being so important, okay, and so close to application layer protocols, we put them in the edge of the internet. Now let's take a look at the exact functionalities of DNS.
DNS services. There are multiple services actually DNS provides. First is what we've talked about, the most basic one, from the host name to IP address translation. It does 3 other forms of translation. First is the host aliasing. So what happened often on the internet is that some hosts came with the host names, but the host names could be slightly longer, indicating where it is or which one of it, number 1, number 2, number 3. Okay, so those can still be slightly harder for users to memorize. So alias name here is often cute and short and very easy to memorize. So this is where the users know the services are, such as www.google.com. All right, so from alias name, DNS allow the web browser to look up what is the canonical name of the server, and from the canonical name of the server, identify the IP address through one of these mappings from host name to IP addresses. So that's how host aliasing works. Second, mail server aliasing, right? So, I mean, you must have one of these, right? Gmail accounts. If your friend is sending email to your Gmail account, your friend's mail server will need to know who's your mail server. So, who's Gmail's mail server? This thing actually looks very general. It's in fact a domain name, not quite a host name. So what happened in DNS is there are also these entries saying for this domain, gmail.com, okay, all the emails destined to this domain should send to this machine, smtp gmail.com. This we talked about when we were telnetting to an email server to demonstrate the message exchange there. smtp.gmail.com is the actual mail server for gmail.com. So there are also this entry here in DNS service. Okay, and this is called the mail server aliasing service. Last, okay, this one is a bit tricky, but it's growingly popular. It's called the low distribution service. What it does is this: for a host name, there could be multiple IPs that map to it. So IP1, and then the same host name, IP2, IP3, IP4, and so on and so forth. Okay, what happened here is that the DNS might actually rotate, returning different IP address each time a web browser or an email server looks up for an entry, okay, for the particular host name's IP address. So that way you kind of rotate using different physical machines every time, and therefore distribute the load of the service. Why not centralize DNS? You heard in the previous slides, there are multiple name servers and there's a certain hierarchy behind it. So why not just one? Well, it doesn't take long. At the beginning of the internet, there's indeed just one DNS server. But it doesn't take long that we realize when the machine is off, the entire DNS service is off. And everyone on the internet, unless you can memorize the IP addresses of all these servers, otherwise, there's not much you can do. Okay, it's off. Second, every application that needs to find mapping IP address given the name, traffic needs to go there. So very high volume. It gets really busy at times. And hey, those users that are around this particular server will have short delay, but they will always be part of the world far away from a particular machine. So delay not ideal. Some could suffer forever. And maintenance, this is a tricky issue, but it is indeed a problem. There are two perspectives looking at the maintenance issue. One is that the DNS server software is growingly large. When it grows too large, if you want to make just a tiny little change, you need to turn off the machine, update the code until you can put it back running, right? But all you want to do is just to make a small change. So one small change influences the entire internet. Not good. Second, it's also hard to do the maintenance, right? Because if you want to just do some testing, debugging, you have to take down the entire DNS as well. And when the software grows large, chances is higher that you need to do the testing longer, debugging longer. Not good either.
All right, so let's come back to the questions before we move on to talk about the exact mechanism that DNS is using to resolve a name to the IP address. So Min Hong was actually rephrasing the question about Gmail, because there seems to be a function in Gmail that you can withdraw emails you sent earlier. Yeah, that works only when you withdraw the email early enough, because you see that the email goes to the outgoing queue first before the email go out of outgoing queue to the receiver's mail server. Gmail lets you say that if you want to, give up now or have a change of mind now. Okay, so that's what the withdraw function or email retract function. So I think it's probably called unsend a message. Yeah. Boris was asking DNS using UDP to send. Very good. You probably read the slides ahead of time or a textbook ahead of time. DNS use UDP to send these messages. So you could have message drops, in fact. So that's why every now and then also when you click on a web page and the page is not showing up, the delay is kind of long. That is usually not because the server is slow or the network is congested. A lot of time it's because the DNS message is lost. So if you hit reload, you might see, the next try, quickly you get the page because the second query might be successful getting the IP address. Okay, so sometimes when you run into trouble accessing a certain server from the host name, it could be because the DNS server is down, not because the network is down. If you recall, I think 2 weeks ago or maybe 1 week ago, Facebook was down. And that's because Facebook's DNS servers are down. Okay, and Facebook's DNS server are actually outsourced to a DNS company, a CDN company. So that company was attacked. So DNS is a very important process. If it's down, you don't get the IP addresses. And it's almost like the internet is all out because you don't know the IP addresses of the servers you want to go to. It's a very interesting question. Usually you reload, you try again. If it's just a UDP packet drop, then second try you get it. Or maybe try a couple more times. Yeah, Facebook. Yahoo was attacked also, I think a couple years ago, because Yahoo's DNS servers were denial of service attack, distributed denial of service attack. That's why many of the major internet companies move their DNS service from managing locally within the company to some professionals. So these are really good network admins that's maintaining the DNS infrastructure for the company. But even that, some hackers are really good. They can still break into your system somehow or overwhelm your servers somehow. All right, Liang was asking, okay, so keeping the important functions at the edge instead of in the core on the routers. Okay, I understand this is probably a concept that's very challenging, not intuitive at all for you to pick up. It's this because the routers inside the internet in the core. So those routers are important if you recall, right? They are there to forward the messages, right? If without any internet paths to go from arbitrary pairs of source and destination, then you don't get to reach other people on the internet. So these routers functionalities are very important. You want to limit the time you need to install software and have it rebooted. So you don't want to touch the routers and minimize the chances you need to reinstall or upgrade software on routers, or turn it off and then turn it back on. Okay. So we actually move the important functionality such as DNS. It doesn't need to be in the core because it concerns less about which is the right way to forward packets. So we make the routers functioning a very simplistic way and make all the complex mechanisms on the edge so that we can just turn down one particular server and turn it back on, and the influence is localized to a particular region. Okay, I hope that actually that impressed you a little bit more about the differences of designing a protocol such that it only operates at the edge of the internet versus partly at the edge and partly in the core. So we would try to avoid important and complex functions in the core entirely, because we don't want the core of the internet to restart, because it's almost like internet entirely restart. Okay, so just keep that feeling in mind as we go to chapter 4 and 5. I think it will become more clear for you guys. And now let's go to the DNS mechanism. Okay, first let's learn about the components. Okay, so the service there, DNS server, it's no longer just one server. Okay, it's actually a whole bunch of servers. There's a hierarchy there, okay, in the servers.
Therefore, DNS is not a centralized system, but rather a distributed hierarchical system. And this is how the hierarchy looked like. At the top, the root DNS servers. Second level, the .com, .org, .edu DNS servers. The lowest level, or the authoritative server level, the yahoo.com, amazon.com, pbs.org, poly.edu, ums.edu. So what you're seeing here is, hey, .com further breaks up the namespace, and each of these server at the bottom will serve a small range of the names there are on the internet. Right? So distributing the load of the name IP lookup. Now, the process of looking up the IP address in a nutshell is this. Client now wants to get the IP address of, for example, www.amazon.com. What it does is first query the top server and try to find the second level server. Query the second level server, next try to find the authoritative name server, the last level. And then from the last level of DNS servers, finding the IP address for a particular host. And let's talk about each of these name servers a bit more. At the top level, the root name servers. It's contacted by the local name server. Now allow me to explain. This local name server is not in the hierarchy. This local name server is actually very, very close to the client. Typically what happens is that a whole bunch of these end hosts sitting in an ISP will be sharing one. So ISP or institutional network will set up a local name server there for all the users in the domain to send the queries. And then this local name server then will relay the queries to all these servers in the hierarchy. Right? So in a way, the local name server here is the client of the name to IP lookup service. So a local name server contacts the root server first. Right? The root server then will contact the authoritative name server to find the mapping. Get the mapping and then return mapping to the local name server. Now, the trick part is this. Okay, when I say contact authoritative name server, it's not like directly going from the root to the authoritative name server. There's a certain way of rerouting the query until it reaches the authoritative name server. Authoritative name server is really the one containing the name and IP mapping. Okay, the top level knows the second level. Second level knows the authoritative servers. Only the authoritative name servers knows the exact mapping. And you see here, there are not many root servers. There are 13 logical root name servers, but each root name servers now have multiple physical sites. For example, here in Tokyo, there are 5 sites, 37 sites just for the Swedish root server, etc. So there are quite a few in America, but essentially very few of these root name servers. Next, the second and the third level DNS servers. At the second level, we have a bunch of these TLD servers, top level domain servers. They're responsible each for a different top level domains. So top level country domains as well, UK, FR, CA, etc. So essentially this is the last part of the host name there. And each of these TLD server is maintained by some sort of organization of public interest. Some people call them NGO. So for example, Network Solutions maintain the servers for the .com TLD server, and EduCost for the .edu TLD. At the third level, we have these authoritative DNS servers, right? So it maintains the IP host mappings. And it could be maintained by the organization itself or by a service provider if the organization is somewhat small and there are not many entries really. Local DNS server, this I tried to introduce earlier. It does not belong to the hierarchy, 3 levels. It's very special. Each ISP or institution network will set up one, and all the clients in the institution or in the ISP will configure themselves to send all the queries to this local DNS server, which is also called the default name server. So when a host makes a DNS query, query is always sent to the local DNS server. Now, these DNS servers often carry these caches of recent translation. So whenever we get a host to IP address mapping to the local DNS server, of course, forward the answer back to the client. But in the meantime, the local DNS server also keep a copy of that, okay, for some time. And this is for the benefit that if the client is looking for the same name again, okay, same name IP mapping again, then it's conveniently already cached in the local DNS server, avoiding going all the way to the hierarchy. So nice. But be careful. These entries could sometimes go out of date. So while these entries are cached locally on the local DNS server, well, the entry might have been changed in the authoritative DNS servers. Okay, although very rare, but there's a chance. So these local DNS servers, if you think about it, it works more like a proxy server. Okay, it's not exactly client. It's not exactly server, it's something in the middle, helping relaying the queries, relaying the answers. Okay? So, helping forward queries into the hierarchy if there's no hit here at the cache.
So does that remind you of the proxy server for web, the web cache? Yeah, they look very similar. They function similarly as well. Last is how we get the DNS resolution or DNS translation.
So far, we've learned that there's a hierarchy in the DNS servers. There's the top, second, and the third level. And we also know that there's a proxy server there, always working on behalf of the client, sending the DNS queries. So let's try to explain further from the local server here how the query is forwarded. Okay, and eventually receiving a reply. And let's do that through an example. Okay, there's going to be a host trying to reach Gaia.cs, but before messages can go out, CIS, poly here, needs to find the IP address of Gaia.cs over there. And we're going to illustrate this form of query forwarding. It's called the iterated querying. All right. So what the local DNS server does is to contact the server in the hierarchy. And the server will reply with something like this: name of the server to contact. Okay, someone who might know a little bit better, but I don't have it. So messages looks like this. Root server might say, hey, I don't know about Gaia.cs.umass.edu in particular, but you may ask, hey, the top level domain server for .edu. Okay, someone knows slightly better than I do. Okay, but I do know someone who knows better. So that's the general idea. And so the process goes. Client here, issuing query. Local DNS server now forwards the query first to the root. Root returns the IP address of the .edu TLD server. Therefore, the local DNS server could re-forward the query to .edu TLD DNS. Top DLD DNS does not know the IP just yet, but top level domain DNS does know the IP address of the authoritative DNS server, so that will be sent back. And the local DNS server sends the query the third time. Okay, to finally the authoritative DNS server. And finally, the IP address for Gaia.cs comes back to the local DNS server. Local DNS server forward that back to the requesting client and be happy about it. Recursive query is the second form of doing the querying. So local DNS server here will forward only to the root, okay, and not contacting DLD, not contacting the authoritative DNS server. And it will be the root's job to find out what the mapping is. And root doesn't really know the mapping of gaia.cs.umass.edu. So he forwards the query to TLD. TLD forwards to authoritative DNS server, and finally the IP address traverse back, and root DNS server here sends back to the local DNS server. Right? Can you see an issue with this? Yeah, so this way of querying puts burden on named servers that's high up in the hierarchy. There's gonna be a lot of query comes to the root. And there's gonna be a lot of queries coming from the root to the TLD, although the load on the authoritative DNS server remains the same, right? So heavy load at the upper level of hierarchies, not good. Keep in mind, there are only some tens of root DNS servers, physical root DNS servers. If everyone is sending the queries always to the root, we could quickly bring down all these root DNS servers. And that's not really a viable solution. Therefore, recursive query is an option that we try to disable at the local DNS server.
And that takes us to quiz 12. Okay, we're supposed to have 2 quizzes today, but because of the time we spent talking about the exam, we'll have just quiz 12. Okay, and here it is. I don't know about you, every now and then, Polly would ask herself, what am I doing here? Okay, so maybe you ask also, hey, it's time to get real. Okay, you decided that this is enough college education for you. Okay, and you thought that I have this business idea, and I've learned enough Golan that I can write something like Facebook. Let's call it Petbook. Okay, Petbook, you think it's gonna be much better. Okay, it's a social net service for pet animal lovers. Okay, using the pet's picture as the profile picture, for example. This is gonna grow bigger than Facebook. Okay, so what I'm showing here is an example of what the pet's book might look like. Okay, and I'm using Honey's headshot here. Okay, in place of mine. Okay, that's much cuter. You see, don't you agree? Mm-hmm. Being also your own CTO, in addition to CEO, CFO, COO of Petbook, try to structure the server network of your service and direct the pet page queries so that the server load is balanced and the delay for your customer is low. Now, to be more specific, I ask, would you prefer modeling your server network, okay, using something that we see in DNS or in SMTP or in HTTP, or a combination of them? Okay, so to bring you guys into context and as a way to summarize what you've learned so far, right? Oopsie. So we've learned HTTP. The communication model is what? Client to server. Oh, I'm missing the very left side of the slide. Okay, so on the left, there's a client. Maybe I could change the way I display. Okay, give me a little bit time. Okay, now this is much better. So you see, this is the communication model, the architecture of the web service. Okay, you have HTTP client and talking to HTTP server. What about email, SMTP, right? Email sender here, sending email to local mail server pushing the email out to the receiving mail server, right? Okay, interesting. They look already different. What about DNS? What we just learned now is what? Client sends query to local DNS server. And then, hey, to provide an answer to that query, we have like a 3-level hierarchy here now, right? So if you look a little bit closer, you see the client side, the client end. Okay, there seems to be some change. Okay, you see the client side expands. Okay, instead of having each client requesting services or trying to send queries on their own, we have a proxy here. Okay, so we could kind of cache some of the frequent answers that the clients within the domain are asking for, within the company or within NTU are asking for. So that can cut down on the use of the link here, right? And we can get quickly answer here. So this is exactly why we have web cache, right? Web cache is to have a proxy server here, which is exactly what SMTP email is doing by default. Okay. But from SMTP to DNS, do you see expansion as well? Yes, but the expansion is at the what? The server side, server end. So one server nowadays, not enough for huge internet services, because DNS is serving all the application layer protocols. So the amount of queries DNS servers receive is overwhelming. Okay, much more than an individual mail server, than an individual web server. So we cannot have just one DNS server, and we ended up having a hierarchy of servers. And at each hierarchy, at each side, okay, within a hierarchy, we have multiple physical servers. Okay. Now for Petbook, which model would you use? And tell me why. So definitely, this is a long question. Please do take time. And when you come up with the solution, type it up on Slack. Let me go to Slack here. Okay, I see Team 2 already type up something, and Team 4. Okay, but this is a long question, so feel free to take your time. Oops. So let me play the Jeopardy music. So you have at least 5 minutes. All right. Okay. So let's address some questions and then come back to some of the teams who have already some ideas and how they try to address the issue. So I think first is Liang Yu asking about whether the iterative queries is better. Iterative queries are preferred indeed, generally, by the local DNS servers. Okay, but this is actually changing. Recursive queries are becoming popular. And this has something to do with how hackers are becoming these days. If you recall that I mentioned, the DNS services are now outsourced to some CDN companies. So these CDN companies are professionally managing your network for you. So, yeah, sorry. Inchi, so I'm just teasing with you. I'm just teasing. So this is because many major internet services, major companies like Facebook, they outsource their DNS maintenance to the CDN companies. So the authoritative DNS servers are usually within the domain. So Facebook's authoritative DNS servers used to be within facebook.com. But you see, if they are keeping the DNS servers within facebook.com and Facebook's admins are not that capable defending the hacker attacks, the DNS server was brought down. And no one can reach their Facebook pages. And so when I say that the CDN companies, content distribution network companies, this we'll talk about, but in 2.6. Okay, it's just that nowadays the CDN is pretty much everywhere, providing services for not just content, but also DNS and many other things. Okay, so the authoritative DNS servers of Facebook is in fact in the CDN company serving Facebook nowadays. So if we use iterative query, you see that it goes to root, right? Root says go to the top level. Top level says you go to facebook.com or umass.edu to find that authoritative DNS server. But you know what? Facebook.com doesn't have that authoritative DNS server anymore. You see? So for these major services, local DNS server, your local DNS server sends query to root. And root sees that, so this is actually a query to a company that the company prefers, recursive queries. And then the root would send the query recursively. So what goes behind root, we don't know. The local DNS servers don't know. Okay, so that actually get redirected to the CDN, and CDN redirect them to the servers allocated to Facebook to host Facebook's authoritative DNS server. Okay, it's a little bit complicated. So you see that internet is becoming something that's very interesting. The design, part of it is to try to make the efficiency higher, to make sure the load is more balanced. But there are some other reasons, economic reasons, as well as security reasons, such that it's not necessarily better that the performance is always the best. Okay, I hope that addressed the question. And let's come to the solutions for quiz 12. Okay, so team 2 here. Okay, very interesting. Team 2 would use SMTP plus DNS. Okay, but in case the company is poor, maybe just the HTTP model. Okay, so that's a very that's good thinking, right? Because at the startup phase, usually the company doesn't have much fun. Okay, so instead of investing big there, installing levels of servers, maybe it's better to start from just simple client server. Once it grows, then you expand the client side and then expand the server side. So usually you expand the client sides first and then the server side. Chunmao here, representing Team 4, is saying, upload the post or blog by SMTP. So you guys, Team 4 is thinking about creating a page or updating a page, right? So that can be more like SMTP. You don't need a complex server because the load is probably low, right? Because you only update infrequently. But to query to get the page, maybe something that's something that's more elaborated. Okay. Team 7, SMTP for sending messages, DNS, for access. So updates, insertion, lower frequency, so just SMTP, having a local cache should be enough. Having a local proxy should be enough. But for queries, that's a lot more frequent. Then you use an extensive hierarchy. Okay, team 3 here use a combination of all three. All right, let's see what you want to use different models for. DNS can help web translate domain name to IP addresses, easier use for users. Okay, great use for expansion. All right, so this is also for access, frequent access. SMTP to send or upload. HTTP allows users to access the web page with shorter delay time. Okay. Because going through levels of hierarchy delay longer. Yeah. So during the phase that you care less about load, but more about time, then you use HTTP. Very interesting. So maybe for certain pages, when the customer demand lower delay, then you use the HTTP model for those customers. Team 10, grabbing and sending text data, SMTP. Yeah. DNS for other requests. For queries, definitely. We just dropped out of college. It's more likely that our resources are only enough for HTTP. Yeah. Good point. Good point. Qian, I think we would like to use both SMTP and DNS to make sure the delay is low when sending messages. I guess you guys are also thinking about having direct messagings between the friends on Pepbook. Okay. So the server load is balanced. So in case there are too many queries, then you use DNS to balance the load. If we think that the Pepbook is really going to be bigger than Facebook, then yes, of course, DNS. It means that there will be a super huge number of users. Exactly, you've got the point here. Boris here. Oh, okay, so team 13, you guys' answer is always long. Okay, wow. Okay, so let's see. Oh, okay, wait. I need to come back because our time is up. Okay, our time is up. Let's not go too long. So, I will go down the list, but our time is up today. Those who need to go grab lunch, because there will be other lectures right next to lunch, feel free to just leave. You can always come back to the YouTube and check out the remaining part of the discussion. But these are just going through the other teams that we have on the Quiz 12 channel. Okay. Let's see. And then goodbye for most of you. I'll see you next Wednesday. Okay. I got a call. 1 second. Oh, Yanjun. Okay. But Yanjun, you're still online. I hope it's okay. Hi, Yanjun. Okay, so you might want to mute the audio from the YouTube session. Otherwise, you would be confused.
Hello, Polly, can you hear me?
Yes, I can hear you fine.
Okay. I'm kind of confused with the answer from Team 3, I guess.
Team 3?
Yes, because
all together?
yeah, because they mentioned to use a DNS model to translate the domain name to IP address. But I think that such service is kind of out of our server because
Okay.
we always need a DNS, right? For
Yeah,
users
yeah,
to
yeah, yeah.
yeah.
Yeah, I think it's just that Team 3 is not exactly precise. I think they meant that DNS is used to do name to IP address. So I think they meant more that they would use the model of DNS as a way to expand reach to Petbook. So in Petbook, when you send a query, it's almost the same to find the server IP address. I mean,
Oh, you mean like I send a query for someone's page?
yeah, exactly.
Oh,
Yeah,
okay, I see.
yeah. So you need to go to a server to find out exactly which server would have stored the pet page. And the pet page might be in that server's particular directory and particular file name, things like that. Okay, so if you think about it in general, it's also a translation service.
Yeah.
Except that in that translation from a query to a petbook page, the petbook page after getting the host name, if you think about a web query, right, a host name and then directory and file name, that host name, that server name needs to be translated again using DNS. I think that's where you get confused. So in a way, the query for a particular pet page is to, after you click, okay, that URL is requesting a page, and the page might contain just like the name of the page, the user of the page, okay, or ID of the ID of the user. That ID needs to go somewhere and get translated to which server is hosting the page of the ID, and what directory and what file. You see?
Okay, I think I understand. So it's also about how the pages are stored and how the
Exactly.
translation takes
Right,
place.
right.
Okay.
Of course, you can design your pet page to contain exactly the IP address, right? Then you can get around DNS as well.
So it's also okay that we don't follow one of the three models, but a combination of kind of like hybrid hierarchy.
Yeah.
Okay.
I think the students here are actually thinking of using different model for different functions. So Petbook, I thought that you just create a page and people query for your page, but some of you guys are probably thinking about doing something very similar to Facebook, to have a messenger sending messages directly to each other. In that case, for that function, you use SMTP. But in the simplest form, to query a pet page is almost like sending a web request. If you think about it, right? Facebook, you click on a particular user, it takes you to the user's page. Okay, it's like that. But Facebook has also the search function. Okay, that search function is obviously a lot more complex. All right, so I hope that addressed the question. Is that all?
Okay, I'm still kind of
Confused?
but I might need to take a bit of
Okay,
time.
think about it.
Yeah. Okay, final question.
Sure.
I wonder if I can, for example, I can use the DNS structure, however, use HTTP as the communication protocol.
Oh, is that what you meant? Okay, so when I say a model like DNS, like SMTP and HTTP, I actually meant only the structure of the network, not necessarily the exact protocol.
Oh, okay. You mean the like
Yeah.
servers and client? Okay.
Right.
So
Of course, you could have a server structure looking like DNS, but between all the servers, you use HTTP type of messaging.
Okay, got it.
So it's all up to you, in fact.
Kind of complicated. It require a lot of like background knowledge searching.
Right. So a lot of time what we do is we borrow existing protocols because We don't have to implement everything from scratch. But it's okay to implement your own messaging protocol and to come up with your own unique way of architecting your server network or the client network. I guess the point I want to make with this quiz is that there are ways of bringing up your own service. So in the second part of the PA assignment, you will see you can implement from scratch. You can also borrow existing protocols. So many of the video services we see today, it's actually built on HTTP.
Okay.
And HTTP was defined to send web pages.
Yeah.
It doesn't seem to be a good fit, but still, people are sending videos on top of HTTP.
So that's kind of the borrowing, as you mentioned.
It's very common today.
Okay, I think I got it. Thank you.
You're welcome.
Bye.
Bye. Okay, let's see. Team 10, SMTP with DNS for other requests. Okay, yeah, we already went through Team 10 and went through Qian's. Team 13. Very interesting. F friend and T friend. Real friend and the false friend. Wow, interesting. Yeah, when you are sending messages to true friends, you use something that comes with shorter delay. Interesting. And access someone else's petbook profile. You would use the DNS model, and you use URL. I see. Interesting. Okay, so obviously Team 13 here is combining not just the network structure, but also the messaging protocols, okay, from various protocols we have already. We think we want to use SMTP and all of them together. Yeah, because DNS does better for load balancing, HTTP with shorter delay. Ming Hong, Team 14. Okay, so you guys are all proposing using a particular structure to do something. I see. I think I see better why Yeming is asking the question. Yeah, so I think in the quiz slide, what I ask is what kind of architecture you would use for your petbook server network. But you guys actually also borrow the messaging protocols of these various protocols before to really send messages, send queries. Okay, got it. That's where you probably get confused. I did not meant to ask you to think about doing the messaging, but you guys thought about it. This is great. You see that as long as it makes sense, as long as it will work, it's all okay. Internet, you'll find that for each application, there could be some very curious way of how it's implemented. Okay. Team 12 also using 3 protocols: DNS to register domain. Okay, so I guess Team 12 also understood it another way. So use DNS to set up name service. Emails to send emails, SMTP to send emails, HTTP to set up web pages, I guess. I see. Team 12, definitely. Sorry, I was not very clear about the quiz. I actually meant Just that what structure you would use for the server network to resolve a query to a page, to a pet page. Sure, this is the office hour time, so feel free to call. Okay, I see. So maybe next Wednesday at the beginning, I would also explain a little bit what I meant to ask. Okay, before I end the stream, let me just answer this. I think there's a major confusion here, definitely. Yeah, I see what you're saying. I think some of you are probably proposing to send the messages like as emails, and therefore you use SMTP. Okay, so that's not what I meant to ask. I actually meant to ask, how do you address when someone is asking exactly where exactly a pet page is? Okay. Yeah, so clarify. Okay, good. So let me do one more thing. Sure, go ahead. Yeah. Yeah, feel free to go, guys. All right, let me end the stream now.